Today we'll be solving a question on the composite grid circle sailing topic. So we'll start with the question. The question says that you have to find the initial course, the final course, and the distance along the composite circle track between positions A and position B. And the limiting latitude from the composite track is 55 degrees south. So the vessel cannot go anywhere south of 55 degrees. Alright, so let's start with drawing the figure because drawing the figure is the most important bit in this question. So you need to be thinking very carefully before you draw this figure. So if you can see that I have drawn the figure, and you must be wondering why A is on to our left side whereas it is east, and B is west but it is on the right side. So to understand how to draw it, you have to figure out the shortest distance between the 2 points. So to do that, just find out the d long between A and B. So whenever you see that A and B, the d long would be 170 degrees 45 minutes east and 075 degrees 50 minutes west. Now ideally the east should come on the right and the west should come on the left, but because the d long between them and opposite names, you go to add them. If you add them, the d long comes to be more than this is actually 246.35 degrees, right? 35 minutes. So the d long between them would be more than 180. So whenever it is more than 180 degrees, you take it off 360. Alright, so you take it off 360 and then you get the answer, which I'll show you that I've got later on as 113 degrees 25 minutes. And whenever this happens, and you reverse the direction as well, whenever this happens, whenever the calculated d long comes more than 180, then you must view the figure from the point of the anti-meridian. Alright, so you go around the earth and you go and look at the anti-meridian, you look on the opposite side of the prime meridian. So then the east and west are reversed. So you have to figure out the shortest distance between before you draw the diagram. So you figure out the shortest distance, and you can see that I've drawn it with respect to the anti-meridian, where 170 degrees 45 minutes east comes on my left side and 75 degrees 50 minutes comes on my west, comes on my right side. So that's why I've drawn the figure like that. Alright, so once you draw the figure, then you have to label the figure. So PA becomes 90 degrees minus the latitude of A, which is 45 degrees 54 minutes, and PB becomes 90 degrees minus latitude of B, which is 49 degrees 6 minutes. Alright, because P is the pole here and we are talking about the south pole, so we are looking at it from the south pole's perspective. So from P, so the latitude is drawn from the equator. So if I erase all these calculations again for you guys and I show you what I mean here. So if you draw the figure, basically we are drawing it with respect to the so this is the equator, 0 degrees, and this is the latitude, right? This is the latitude of B, which is equal to 49 degrees 06 minutes south. So therefore PB would be 90 minus the latitude of B, which is 49 degrees 06 minutes, but subtracted from 90 degrees, which is 40 degrees 54 minutes, because from P to the equator is 90 degrees. So similarly PA is equal to 44 degrees 06 minutes. In this case the limiting latitude is 55 degrees south, so therefore the latitude of the vertices, which is V and W, and I've named it V and W, you can name it anything you want, this is 55 degrees. Therefore PV equals to PW, which will be equal to 90 minus 55, which is equal to 35 degrees. Alright, and the last thing that is remaining is this angle here, angle P, which is the d long between the A and B, and we have found out d long before, so you know how to do that. So you can see that the d long is 113 degrees 25 minutes. Alright, so once you've drawn the figure and you label the figure, make sure you have a careful look to avoid making any errors. You should verify it as many times as you want to, because do not proceed with the solution before you have verified the diagram and you verified the figure, because if the figure is wrong, then all your answers will be wrong as well. Alright, so spend some time in drawing the figure and labeling the figure. and only when you are sure that you've drawn it correctly should you proceed. So we'll be solving this question in 3 triangles. So the first triangle will be triangle PAV, the second triangle will be triangle PWB, and the third triangle will be triangle PVW. Alright, and we'll be using Napier's rules for triangle 1 and 2 and the principles of parallel sailing for triangle 3. So let's start with triangle PAV, which is triangle number 1, and again we'll be using Napier's rules, for which we need a 90-degree angle. Now the 90-degree angle is provided by the vertex here, so you can see this is 90 degrees and this is 90 degrees because here the vessel is doing parallel sailing. Alright, so because it can't cross the limiting latitude of 55 degrees. So what we do is we draw the Napier's diagram, and then angle V, which is 90 degrees, comes outside the Napier's circle. The sides next to V, which is PV and AV, come next. Then the angles opposite to PV and AV, suffixed with 90 minus, come next, and then 90 minus PA is the only side left, which comes in the center of the bottom semicircle. In this circle, you know what is PA because you have found it out, and you know what is PV because you know that as well. Right? We know PA and PV as you have drawn in the figure. PA and PV are the values given to you. Now you will be using these two values to find out firstly the initial course, which is angle A, as well as AV, which we'll be using to calculate the distance later on. Alright. Additionally, you will also find out angle P in triangle PAV. We'll call that P1 later on. So let's start with P. So we have sine 90. So we'll be using the ones that we know to find out the one that we don't know. So the first thing that we will be using is finding P. So we'll be using PV and PA. So to get all of these three values in the same equation, sine 90 minus P becomes the middle part, and tan PV times tan 90 minus PA becomes the adjacents. Alright, so sine 90 minus P is also equal to cos P, which is equal to tan of 35 multiplied by tan of 90 minus PA, which is tan 45 degrees 54 minutes. Cos P then will be equal to 0.72256. I have stuck to 5 decimal places. You can go to more decimal places if you want. The more the decimal places, the more accuracy you get, which will give you P is equal to 43 degrees 44 minutes. But I'll call this P1 because I'll be finding out P in angle PWB as well, and that might complicate things if I call that P as well. So, and then we have a P, which is the big angle P, the D long between A and B. So let's call this P1 to avoid any confusion. Alright, then what we'll do is I'll keep going. So the next thing we have to do is find out, I'll erase this. Next thing we have to do is find out what is the initial course, which is angle cos 90 minus A, so which is angle A. So what we have to do is basically we have to involve what we know and what we don't know. So we have to involve these three values in the equation. So when you involve these three values, don't try to use P because P is something you have found out. So if there is any error in P, you will carry that error through. Always use the ones that you have known before to find out the one that you don't know. So therefore sine of PV becomes the middle part equals cos of the opposites, which is cos 90 minus A multiplied by cos 90 minus PA. So cos 90 minus A is also equal to sine A, and cos 90 minus PA is also equal to sine PA. Sine PV equals sine A multiplied by sine PA. Alright. Therefore, keeping sine A here because that is what we have to find out, I'll be taking this here. This becomes division. So sine A equals sine of PV divided by sine of PA. So sine A will be equal to sine of PV and divided by sine of PA. Put in the values of PV and PA. You get sine A equals to 0.82420. Make sure your values match with mine. In this case, A equals 55 degrees 30.5 minutes, or you can round it off to 56 degrees. But you can see I have named it southeast. Now how have I done that? So if you look at the figure, this is how the vessel is proceeding, right? And this is looking at it from a south pole's perspective. This is A and this is B. So this angle is the initial course. Alright, so if you look at it from a south pole's perspective, and this is south and you are going in easterly direction, the first quadrant that comes into play is the southeast quadrant. So as long as the value is less than 90, the first quadrant that will come into play is the southeast quadrant. If it is more than 90, then it will go into the next quadrant, which is the northeast quadrant, when we are looking at it from the South Pole's perspective and when the vessel is going easterly. Alright, so that is why A will be, because the value is less than 90 degrees, it's still in the southeast quadrant, so I have called it south 55 degrees 30.5 minutes east, or south 56 degrees east, which is equal to 124 degrees true. Why? Because if south is 180 degrees and you are going towards east by 56 degrees, you are somewhere here, which is 180 minus 56, which is 124 degrees. Alright, so then we keep going and we have to find out AV, because that will be part of the composite great circle distance. So to do that, I'll come back to my Napier's diagram. I will erase the one that I have found out, and I have found out A as well, so I'll forget A. Now I have to find out AV. Alright, and I have to use the ones that I knew from before to find out the ones that I didn't know. So I have to involve these three values in the equation. So because of these three values in the equation, my sine 90 minus PA becomes the middle part, which will be equal to the cos of the opposites, that is cos PV multiplied by cos AV. Sine 90 minus PA also equals to cos PA, and because AV is unknown, I will take cos PV onto the other side and it becomes division. Therefore cos of PA divided by cos of PV will give me cos of AV, or cos of AV equals to cos PA divided by cos PV. Just put in the values here of PA and PV. Alright, then of course cos comes here, cos inverse of this value here will give you the AV, which is 28.75 degrees. Now because AV is distance, I will convert it into miles by multiplying by 60. 1 degree equals 60 miles, so I will convert 28.75 degrees into miles by multiplying it with 60, and I get 1725.4 miles. Then I go on to my next triangle, triangle number 2, which is PWB, and I'll draw the Napier's diagram again, keeping my angle 90 degree angle outside the circle. Again, in this triangle or in this circle, I know PB and I know PW, and I need to find out all these three, because BW will be part of the distance, B will be giving me the final cos, and P here will contribute later on towards the distance as well. I'll show you how. So let's find out first angle P. So to do that, I have to involve these three values in the equation, just like I've done before. I will not take you through all that explanation again. So sine 90 minus P becomes the middle part, and then we have the tan of the adjacents next to it. Similar to before, find out angle P, and this time call it P2, otherwise we'll get confused as to which is angle P. Now there's will be too many angle P's, so we'll call the P that we have found out using this triangle here, and we call it P2. Alright, so once we have found P2, we'll start with sine of PW. So what we have to do now is find angle B, because that will give me my final cos. So to find out angle B, I will erase this. I have found out P, so I will erase this. So now if I have to find out B and I have to involve the ones that I knew to find out the one that I don't know, this will be the equation, right? So sine of PW becomes the middle part, and then cos of the opposites. So again, cos of 90 minus B is equal to sine B, and cos of 90 minus PB is also equal to sine PB. And we have sine PW. B is the unknown one, so I will take this unknown known here. So this will give me the value of B. This is sine inverse. So B I'll get as 61 degrees 10.1. Or to make it easy, I'll keep it 61 degrees. Now why am I rounding it off? Because these are courses, and courses cannot be steered in decimals of minutes, so it's better to round it off, but then you follow the instructions of your lecturer, of course. But for all practicality, I like to round off the distance courses, because it's the practical thing to do. Now what I have got is the internal angle B. Now if I look at the diagram again, this is the angle I have calculated as 61 degrees, but that's not my final cos. My final cos is this outer angle here, but this is from the south pole. if I need to measure it from the North Pole, this becomes my final course, right? So I can say that opposites will be the same angle. So I will have north 61 degrees east, or I can also look at it from this point that this angle is 180 degrees. Okay, let me draw it again so that you guys don't get confused. This is A and this is B, and I'm going like this. Then I'll use a separate pen. This total angle is 180 degrees. If this is 61 degrees, then the outer angle B will be 180 minus 61, which is 119 degrees. 119 degrees would mean now I am no longer in the southeast quadrant, but I have gone into the northeast quadrant. How? If this is north and this is south, this is east. If I say this is 119 degrees, that means up to here is 90 degrees, and I am now 29 degrees into the other quadrant. 90 plus 29 is 119 degrees, right? So if it's 29 degrees into the other quadrant, that means I am north 61 degrees east is my final course. So that's why my final course is 061 degrees true, or north 61 degrees east. Alright, then I go on to find out BW, because I need to add it to the distance later on. So again, BW I will find out, and let me erase all this. So if I have to find out BW, I will be using this here. Right, so come back to my red pen. Sin 90 minus PB will be equal to cos of PW multiplied by cos of BW. This comes here, and I've shown this all before as well. So find out BW, match the values with my values, and you will get BW as 22.67 degrees. But because this is distance, convert it into miles by multiplying by 60. You will get 1360.3 miles. Now finally we will use the P1 and P2 values. Now angle P, which was the overall D long between A and B, was 113 degrees 25 minutes. But that angle P comprised of P1, P2 and P3. What is P1, P2 and 3D? Well, let's go back to the main drawing here. Alright, so if I can show you using a different color, this angle is P1, this is P3 and this is P2. So we have found out P1 and P2, but I have to find out what is P3. And I can find out P3 because I know the overall angle P. And if I subtract P1 and P2 from it, I will get P3. So this is what I have done here. So P equals P1 plus P2 plus P3. I know angle P, I know P1 and P2, so I can find out P3. Right? So I found out P3, which is equal to 33 degrees 41 minutes, which is also equal to 2021 miles. Alright, so if I multiply the degrees, 33 by 60, and then add 41 miles to it, it will be 2021 miles. Then what I'll do is I'll put it in the formula here. Departure equals D long multiplied by cos of lat. My D long is nothing but P3. Now which part is this? This part is the final triangle here. V, W and P. This is parallel sailing. The vessel is sailing parallel here because it cannot cross the latitude of 55 degrees south. I have found out this angle here, which is P3. This is my D long. So as per the principles of planes parallel sailing, departure, which will be equal to VW, will be equal to D long, which is P3. So D long is P3 converted into miles, which is 2021, multiplied by cos of the latitude, which is 55 degrees, the limiting lat. And you get the distance of 1159.2 miles. The total distance in this case then will be AV, BW plus BW. When you add the three distances together, you get your total distance as 4244.9 miles or 4245 nautical miles. Alright, so this was the composite circle sailing question. I hope it was clear to you. I know there could be some problems with the determination of the final course. It gets a bit complicated. Then just simply use the principles of opposite angles and name it accordingly. Alright, So let me know what you thought about this video, and I'll make more videos like this so that you can get an idea of practicing questions like this for your exam. I'll see you soon with my next video, guys. Bye.